One of the critical skills you'll need when dealing and working with thermodynamic problems is to be able to read and interpret a PV diagram or a pressure volume graph. So just a review from graphing from the beginning of the school year, anytime you look at a graph, it's always important to look at the axes. Then you want to look at slope. And then you want to determine if area has any meaning. So if I look at this graph, I see right away that we've got pressure on the y-axis and volume on the x-axis, and that actually is because of the way that it's named, PV, that whatever comes first goes on the y-axis, and then whatever comes second is on the x-axis. Okay, so check. Looked at my axes, looked at the scale. The next thing, slope. Slope is rise over run, and in this particular graph, it's pressure over volume, so slope actually has no meaning for us on this graph. So now we get to area. So area, it's just, you have a triangle, 1/2 base times height, or we have pressure times volume. So the area on a PV diagram is what we're going to focus on. So area is going to represent work. You will need to be able to calculate the work done. So area under the curve will be the total work done in that process. So usually the processes, so you have this point A to point B, you have point B to point C, so it would read something along the lines of process AB, process BC, or process AC. So let's just look at process AB. I want to know how much work was done in that process AB. So we have to get area under the curve. So if I look, I have my blue line. So the area under the curve is actually going to be this whole area. So we've got the area of this triangle and the area of the rectangle. So to get that area, it's going to be, I'll do 1/2 base times height plus that base times the height. And now I just need to plug my numbers in. So we'll have 1/2 base, or let's do the height first. So 1/2 the height, so 5 minus 1 times, then you have 50 minus 10, and that gives you the change, plus I'm going to do the base times height of the rectangle. So we have 1, it's not changing, it's remaining constant. So then we have 50 minus 10 for the change in volume. And notice the delta is only on the change in volume. Pressure, you always have to have some amount of pressure because you've got gas in a container. So the PV diagram is showing you how much work is done by a system of gas. So pressure is remaining constant at 1, and we have our change of volume for this second part, so it's 50 minus 10. So then all that's left to do is plug your numbers in. So 1/2, 5 minus 1, and I'm using my parentheses, times 50 minus 10, plus another set of parentheses, that 50 minus 10, and we get here that the work, let me change colors, the work is going to be equal to 100 joules. But I'm not done because we just calculated work, so now we have to figure out the sign. So if the volume is increasing, that is negative work, or if the volume is decreasing, it's positive work. So from A to B, who cares about pressure, we're going from this point to this point. So volume is increasing, so we get negative work. Okay, so that takes care of process AB. So now, how much work is done by process or during process BC? So process BC, I'm now going to use yellow that takes care of this portion of my graph. That's the area under the curve. So work is going to be equal to base times height. The units on, the numbers on our graph. So we'll have for our pressure, it's constant. So I'm going to do over here, this is 1, it's not changing, or 1 Pascal. And then the change in volume, so we have 50 minus 10. So 50 minus 10 gives us the work done as 40 joules. Now we need to go and figure out the sign. So I can look at from B to C, my volume is decreasing. So if my volume is decreasing, this is going to be, let me use red, this will be a positive 40 joules. It'll be a positive work value. And then we have one more process. So in process A, or let's do C is first. So it's process CA. If I look at that, there is no work done. Well, the reason there's no work is because of what, I stated this in an earlier video, is work is all related to the change in volume. So if we keep this in mind, if there's no change in volume, who cares what the pressure is or how the pressure changes? 0 times anything is 0. So no work in that first process because there was no change in volume. So process CA, no work. All right, besides being able to just look at the volume and increasing, the other way that you can tell if you're going to have positive or negative work is by looking at the direction of the arrows. The arrow shows you what direction the process is going. So if your arrow is pointing, obviously directly up would be that process C to A, so there's no work. But the other part is if my volume is increasing, my arrow is actually pointing to the left, and you can see that, it's left-ish. But if my volume is decreasing, your arrow is going to be pointing to the right. So this right here will tell you if your work is going to be positive or negative.